Hello everyone, welcome to the second module of Data Analysis with Python full course. This is Sumit Shukla, Senior Data Scientist and an educator. In this particular video, we'll be talking about data visualization using Matplotlib and Seaborn. So let's get started. Hello everyone. Now in this particular video, we are going to talk about how to perform data visualization in Python using two very popular libraries known as Matplotlib and Seaborn. So before we start coding on our Jupyter notebook, as of now we are using Google Collaboratory, we'll be understanding the theoretical basics of what exactly is Matplotlib library and what exactly is Seaborn. So let's start. So whenever we paint something, we first of all need a particular canvas, or you may say you need a drawing sheet, right? So assume that this is my canvas or maybe the drawing sheet. Now on top of this drawing sheet, you can paint anything, right? So let's say I have created some good scenery. So here I have created some good scenery. So in total or overall, I can call this as a painting. Now a painting as an overall structure comes with two components. Number one, we have the canvas or the drawing sheet on which we essentially paint. And then we have the actual drawing or the scenery. So we have the drawing, right? Now why I'm talking about this? This is not a painting class, but this is the core concept behind how we visualize data in Python. Let's say I'm having the data like this. I'm having data with the customer IDs, then we have the gender, then we have the monthly charges. Now, if I want to visualize the count of males and female, we will essentially use a bar chart. So how that bar chart would look like? It would look like this, where on the x-axis I'll have gender, here on the y-axis I'll have count, and then we'll have male, female. So male, female. Now, in order to plot this, in Python we need a figure. So over the Jupyter notebook, this plot is created over a virtual space, which we call as a figure. So this is known as a figure. Again, if I connect this concept to the painting concept, this is nothing but my canvas or the drawing area, right? Now this plot is basically my drawing or the scenery which I am wanting to create. So this is my plot that is generated using the data, and if I connect this topic to the painting, this is basically my drawing. Now this is the core concept of how we visualize data in Python. We have a figure, and on top of the figure we create plots. On top of the figure we can create one plot or any number of plots you want, right? Now let's come to the topic of what is the requirement of the two libraries. We have Matplotlib and we have Seaborn. So if I have to perform data analysis, we have the library pandas. If I have to perform scientific calculations or scientific analysis, we have the library NumPy. But why we have so many libraries, or essentially these two core libraries for data visualization? What is the requirement? Let's try to understand it. So let's say this is my plot and this is my figure. This is my figure. And on top of this figure, we have a plot. This is my sum bar chart. Now, if I want to do any kind of changement, if I want to tweak my figure, if I want to increase the size of the figure, and when I am saying figure, I am essentially talking about this canvas, the background virtual space on top of which I keep my plot. So assume that I'm having a A4 size sheet. Assume that this hand is a A4 size sheet, and on top of that we have created a drawing. So this is a virtual space in my Python, and then on top of that we create any kind of plot or any number of plots you want. So if you want to do any kind of change in the figure, let's say you want to increase the size of the figure, increase the size of the figure. So when I say increase the size of the figure, I am basically talking about increasing the size of the virtual space where we have the plots. Let's say you want to add the grid lines in the virtual space. Grid lines. Let's say you want to add the title in the virtual space. So you have the plot over here. This is my plot. This is my plot. Let's say you want to add the title over here. Let's say you want to add the X label, Y label. So title, X label, Y label. Let's say you want to basically you want to change the color of the background. Background color. So like this, if you want to do anything with the figure, with the background, with the virtual space on which we have kept our plot, then we use the library known as Matplotlib. So the library Matplotlib basically helps us to control the attributes of the figure. Control the attributes of the figure. Now, Matplotlib library is not just limited to controlling the attributes of the figure. Using Matplotlib, we can also generate plots. Generate plots. So if you want to generate a bar chart, histogram, box plot, line chart, you can do all these things using Matplotlib. Now we will talk about why we need Seaborn. So let's talk about Seaborn. Now the library Seaborn is only limited to generating the plots using the data. So generate plots using the data. It can only generate plots. So if I'm having the task to do anything with the background, which is my figure, I cannot do that with Seaborn. If I have to generate a box plot, bar chart, histogram, line chart, maybe let's say maybe any kind of plot, then Seaborn is something which can help you. But if you have to do anything with the background, the figure, you have to use Matplotlib. Now you guys must be thinking that if Matplotlib is capable of controlling the figure attributes, as well as Matplotlib is capable of generating plots from the given data, then why we need Seaborn? What is the requirement of the Seaborn? Well, the requirement of the Seaborn is because of its great functionalities. Creating rich plots using Seaborn is very simple. So Seaborn generate plots which are very clean, and it also provides you so much functionalities such that you can change your plot. You can add more varieties to your plot using Seaborn. So creating a plot or generating a plot using Seaborn is much easier than Matplotlib. So using Seaborn, we get variety of functions and much better plots. And that is the reason whenever in Python we have the requirement to generate a plot, to plot my data, my first choice would be to use a Seaborn. And this is my personal choice. Whenever I have to plot anything, I essentially use the Seaborn library to plot something. But if my objective is to change anything in the background or change anything in the figure, then we use Matplotlib. So with Matplotlib, I use it for controlling the attributes of the figure. Now this is what your Matplotlib library is. So in short, or just to summarize, we use Matplotlib library as a core library to control the attributes of the figure. We use Seaborn as a core library to generate plots from the data. And as you can see that on top of the figure, you can keep any number of plots, right? So if my figure is controlled by Matplotlib, and if I'm generating my plots using the Seaborn library, then these two libraries can work together. There is no problem, because Matplotlib is working in behind to control your virtual working area, to control your virtual canvas. And on top of this, you can generate plot using any library. It can be Seaborn, it can be Plotly, it can be anything. Okay, so these are the two core libraries, and I hope you guys understood why we need these two libraries and what is the core objective of these two libraries. Now let's try to understand how to make use of them. Before we jump into the usage, let's quickly understand about the data. Well, you guys already know about it, but I'll just summarize. Well, the data consists of generally two kinds of variables. Number one is your categorical variables. Number two is your continuous variables. So categorical variables are basically your variables that consist of data as categories. For example, gender. For example, let's say city. Continuous variables are those variables which consist of data which is numerical in format. For example, income, total charges, and so on. So when it comes to the categorical data plotting, we essentially use two kinds of plot, and I'm talking about my personal choice or my personal experience in my whole data science journey, which is around 5+ years of experience now. I haven't used so many different kinds of plot, because the plots that I'm going to discuss today these are not many plots, 4 to 5 kind of plots. Your 4 to 5 kind of plot will help you to answer any kind of question which you will be getting in your entire data science journey. So when we have categorical data, I essentially use 2 kinds of plot. One is the bar chart. The second one is the count plot. When we have the continuous data, we have 3 kinds of plot. One is the histogram. One is the disk plot, which is used for plotting the distributions. And the third one is the box plot. And my personal favorite is box plot, because box plot essentially answers all your question and you even don't need the histogram and disk plot. So box plot is, I personally love plotting box plots. So we'll be looking the example of all these things and how we can plot, let's say, 2 categorical variables and how we can plot 2 continuous variables. We'll talk about all of these. So let's directly jump to our Google Collaboratory. Now we have the data already available to us. So this is the data frame that we are going to use. This data is having the various attributes about the customers, defining the customers such as gender, senior citizen, partner, and so on, till we have the target column churn. So whether the customer has left the company or the customer is still an active customer. So we have been given with this particular data in which we have the various attributes defining the customer. We have the gender of the customer, senior citizen, partner, dependent, tenure of the customers in month, then what contract type the customer has followed. Then we have monthly charges, total charges, and finally we have the churn column, which defines whether the customer has left the company or the customer is an active customer. This is the data which we have. Now, let's start with continuous data plotting. Continuous data basically means the numerical data. So in the particular data which we are working right now, we have tenure, then monthly charges and total charges to be the continuous data. And let's try to start with the histogram. So we will first import the 2 libraries, import matplotlib.pyplot as plt, then import Seaborn as SNS. And now, as I told you that we'll be using Seaborn for generating plots. So I'll just simply say sns.displot. Now dis stands for density. Those of you who are not clear with what density is, we already have a very detailed video on probability and statistics where I have talked about distributions, the random variables and distributions. So if you want to understand what density is, you can go and watch that particular video. That will clear all your doubts. What is the difference between probability and what is exactly density is. So here we are plotting a density plot, and then the column that we are interested in is, let's say, the tenure column, and my data is df. Okay, so this does not comes with a data attribute. Let's simply use the column name. Now here you can see that I'm getting a particular plot which is having the tenure histogram. The minimum tenure is 0, maximum is around 70, and we have these histograms defining the count of customers at various range. Now this is a histogram, but what if I want to create a density curve? Well, if you want to create a density curve, the only change that we have to do over here is assign the kind is equal to KDE. Now here you can see that histogram has been converted to a density plot. This is my density curve where the y-axis is the density, x-axis is still tenure. Now what is the advantage of reading a density plot over a histogram? Here in the histogram you can see that I do not have a continuous curve, and looking at a density plot we have a continuous curve, and what we have to focus on is the peak. Now wherever I am having a peak, that basically means the proportion of customers at this point and at this point is higher. If I compare these two peaks, the proportion of customers in the entire data is highest over here, which basically means I am having highest number of customers in the lower tenure range, while there are good number of customers which are less than this in the higher tenure rate, and then in between I am having good number of customers. So you can see that in the left side also I'm having good number of customers, right side also I'm having good number of customers, in between I'm having less customers. So either we have less number of customers who are having average tenure or median tenure, but we are having high number of customers who are having low tenure, and also good number of customers who are having high tenure. If I am a data analyst working for this telecom company, I can just conclude that these customers are probably my new customers who are basically interested, or maybe who have joined the company in last 5 months or 1 month. That is the reason the proportion is highest in this particular range. Here these are my golden customers, or my precious customers, because they have been with the company for last more than 60 months, and these are my median customers. They are neither having very low tenure, not having very high tenure. They are just my median customers, and I would say these are my most stable customers. The reason we are calling them as a stable customer is because they have already completed a cutoff period around 10 months with the company, and they are proceeding towards becoming the precious customers, right? This is what inference we can derive from a density plot. Now, what if I want to change the size of this figure? Because as of now you can see that this figure is consuming a good amount of space in my Google Collaboratory. So if I want to change the figure size, we can either use Matplotlib, and I'll show you how we can use Matplotlib, but specifically for this plot we have the parameters which is height. Let's say I want to keep the height as 2, and aspect ratio I want to keep it as, let's say, 2. Let's see what will happen. Now you can see that I'm getting a very small plot. If I change this aspect ratio, your plot size will change. You can see height is taking care of your height, and aspect ratio is basically taking care of the width. I want to keep it as 2 only, but this one we can keep it as 3, and I'll get a perfect plot, right? So this is how you can work with the disk plot. As I've told you that my favorite one is the box plot, and let's try to create a box plot for this. So sns dot box plot, and I want to create the box plot for tenure. Now here I'm getting the box plot, which is a vertical box plot. What if I want to keep the box to be as horizontal? Because we are much comfortable in reading the horizontal box plot, right? So only thing that you have to do is just say x is equal to df tenure, and you will get the horizontal box plot. Again, this box plot is not looking very nice because it is consuming a lot of space, and it is not properly fitting my screen, right? So the best thing that we can do is to resize it. Now this time I'll be using the Matplotlib library to resize this. Since I'm doing something with the Matplotlib library, I'll be using the PLT name, and then I'll be using the figure attribute. Now, since we are doing with the background, since we are changing the virtual background, the size of the virtual background, and as we have already learned, the virtual background is known as figure. So we are using figure. Then I want to change the figure size. So fig size is equal to, we have height comma width. So height I want to keep it 2, width let's say 3. So okay, width comma height is, it will be width comma height. So 3 comma 2. Maybe we can do it as 5 comma 2 will be a better, 5 comma 2 would be a better size. And you can see that we have the box plot. We have also adjusted the size of the box plot using the figure attribute and the figure size, where figure size takes width and the height, where width was 5 and height was 2. Now if I plot the same thing, so I'll just copy my code, put it over here. If I plot it for, let's say, the monthly charges, so now if I plot it for my monthly charges, you can see that the box plot is looking very similar, but this middle line is at different points. Now let's try to understand the interpretation behind how to read a box plot, because we know if I have to read a distribution curve, we have to focus on the peaks, but how to read a box plot? Let's try to quickly understand box plots. Now a box plot, so let's say this is my income and I'm having a box plot like this. Now, so this particular point represents Q1, this represents Q2, this represents Q3, and Q2 basically means the median line, while Q1 means the 25th percentile, and Q3 means 75th. Now if you already know how to read a box plot, you guys can skip this part, but those of you who do not know it, you guys can focus on this particular topic. So a box plot represents how your data is spread between a minimum value and a maximum value. This is my minimum value, and for this particular box, this is my maximum value, and the distribution is very normal. So if I create a distribution, it will look something like this. This is a normal distribution. Basically mean that in this median point, below this point, I am having 50% of the customers. Above this point, I'm having 50% of the customers. Below Q1, I'm having 25% customers. Above Q1, I'm having 75% customers. So if I want to create, or if I want to derive some inference out of this box plot, I would essentially say that we are having good amount of customers in the mid range, around 50%. So this box in the middle represents half of your customers. So 50% of the customers are in the middle of my data, which basically mean that most of the people are earning the average income. So looking at this plot, I will just derive or maybe conclude that most of the people earn average income. Now if I'm having a box, let's say like this. So a box like this. Now this box represents a right skew distribution. So if I plot a normal distribution, it will look something like this. So this is a right skew. Now what is the meaning of this? So this basically means majority of the customers are on the lower scale. So if I consider this x-axis to be income, most of the customers are earning low income, while these 2 points are nothing but your outliers. So box plot can essentially help you to identify the outliers, and this is my median. This is my median. So below this point I'm having 50% customers, and above this point I'm having 50% customers, but this box represents that most of the customers are on the lower side, where the box has been shifted towards the lower side of my x-axis. And similarly, I can have a box which is right skewed, the left skewed. So in that case, my box can look something like this, and I can have a curve like this. So this is my left skew, and I hope you guys now know how to read a box plot, right? So if we try to go back to the Python result that we have generated, so here we have the result. We can see that the median tenure is around 28. Almost half of my customers in the data are having a tenure of 10 to 55. So most of the customers are with the company for 10 to 55 months, where the median is 28. So below 28 I'm having 50% customers, above 28 I'm having 50% customers. Similarly, if I look into the box plot for monthly charges, the monthly charges for all the customers is around 70. But if I divide this, or maybe if I create a box plot for churn and non-churn customers individually, so let's filter this data for churn customers. So df churn is equal to yes. So these are my churn customers, and the box plot for churn customers. And for non-churn customers, how the box plot would look like. Now you can see that it is having a very clean pattern. The monthly charges for customers who have churned, who have left the company, the monthly charges, the median monthly charges is on the higher side, and you can see the box is towards the right, which basically means I'm having most of the customers on the right side, higher side of the monthly charges. While those who are not churned, you can see the box is shifted towards the left, most of the boxes towards the left, and the median monthly charges is around 63 or something, right? So basically a box plot can better help you to understand the pattern in the data. But here, since we are talking about how to plot, you guys can see there is one problem. If I want to compare the monthly charges for churn and non-churn customers, it would be great if I can put them side by side, right? So we have already understood that how to read a box plot, but right now you guys can see that since they are on two different cells, it is getting difficult for us to read it properly, right? So if I can put them side by side, it will be really useful and easy for anyone to compare. So let's see how we can plot multiple plots within one figure. Let's try to understand this topic. Now let's say this is our figure, nothing but the canvas. This is my figure. On top of this figure, I want to plot 4 plots. So one over here, let's say this is a bar chart. One over here, let's say this is a dist plot. Let's say this is a box plot. And last one is also a box plot. Let's say this is what my requirement is. Now, since I have to plot multiple plots on top of the figure, we'll be using the Matplotlib library to get this happen. Now, Matplotlib library comes with a function known as the subplot. So plt.subplot, this particular function takes 3 input. plt.subplot takes 3 input, a, b, c, where a is the number of rows in the matrix, b is the number of columns, and c is the index number or the plot number. So right now, if I consider this to be a matrix, then this matrix is of 2 cross 2 because it is having 2 rows and 2 columns, right? Also, I'll call this as plot number 1, plot number 2, plot number 3, and plot number 4. Always remember, your plot works or plot number are assigned in the zigzag direction. So I start from here, 1, then 2, maybe if I am having 3 plots, then 3, then 4, 5, 6, and again 7, 8, 9, and so on. We can keep on doing this thing like this, zigzag. So since we are having 4 plots, so 1, then 2, then 3, and then 4. Now we have to write plt.subplot, and we have to define the value of a and b and c. Subplot, a is going to be 2, b is going to be 2. Now the plot number is 1. Below this, I will write the code for plot 1, which is sns.bar plot, or maybe whatsoever we want to plot. Then plt.subplot 2 row 2 column plot number 2. Below this, I'll write the code for the dist plot. So sns.distplot and the name of the column which I want to plot. Then the third plot, plt.subplot 2 row 2 column plot number 3. And below this, I'll write the code for the third plot. Similarly, plt.subplot 2 row 2 column plot number 4, and after this again I'll write the code for the last plot. So here you can see that in the code that I have written for plt.subplot, the parameter a and b are fixated because the matrix is defined that I'm having 2 rows and 2 columns. But the parameter plot number will change, and below each line of code I have to write the code to generate the plot. So assume that this is 1 bucket, 2nd bucket, 3rd bucket, 4th bucket, but you have to write all these code in one code cell. You cannot write them in different code cell. In one code cell you have to write the complete code, and then you will be able to generate all the plots in this matrix like structure. Let's look at one example. And right now the example that we are going to take is to plot 2 box plots side by side. So 1 box plot, then 2nd box plot. Now this is 1 row 2 column plot number 1, plot number 2. So 1 row 2 column plot number 1, then the code, 1 row, 2 column, plot number 2, then the code. And I'll write this complete code in one code cell. Let's do this. So plt.subplot, 1 row, 2 column, plot number 1. Below this, I'll write the code for generating the plot. Then plt.subplot, 1 row, 2 column, plot number 2. And then we will write the code for generating another box plot. Let's run this. And here you can see that we have 2 boxes in one figure. But the figure size is not looking that much nice. We have to adjust it. So we have the figure size parameter. Let's copy it and put it at the end in the top, because first we have to define the figure size and then only we can create the plot. So that is the reason the very first line of code, which should be the part of my cell, should be this figure component. So plt.figure, fig size. Now I will make this as, let's say, 10, and so height can still be 5. Width can be 10 and height can be 2. Let's run it. And here you can see that we have 2 boxes side by side. But I do not know which box represents what. So for that we have to add the title. So we will add the title on top of each box. So plt.title, and here the title is this is the churn monthly charges, and the below one is plt.title, and this will be non-churn monthly charges. So now we can see that we have the title, we have the boxes, and everything is looking so nice. So this is how you can plot multiple subplots within a figure. But still there is one problem. The problem is they are on 2 different scales. How to plot them in one scale itself? Now for that, Seaborn is having one great function, sns.boxplot. Now on the x-axis, I will put the categorical column. X is equal to df.churn, and on the y-axis I will put the continuous column, which is monthly charges. Now just see what is going to happen. Now here we can see that in these 2 plots I have specifically filtered the data for churn and non-churn. But when I have used x parameter as the categorical variable, so here my x is the categorical variable churn, which is yes and no, and y variable is the continuous variable, which is the monthly charges. The Seaborn box plot function has automatically created 2 individual boxes for each of the category. And now the advantage is that we have one y-axis for 2 categories. So it is now much easier to read this plot. Whereas previously we were having 2 individual boxes, but now we have one figure or one plot. Within that we have 2 boxes with the common scale, which make this plot easy to read. So you can compare the median monthly charges. The median monthly charges for those who are churn is higher than those who are non-churn. Similarly, the concentration of churn customer is higher on the higher side of the monthly charges, while concentration of people who are non-churn is on the lower side, right? So this is another advantage of using Seaborn. Now this is something which we cannot do in Matplotlib, and even if I try to do it, it will take a lot of extra line of code to get this happen. But you can see that just by writing x and y and using the box plot function from Seaborn, we were able to generate such a nice clean box plot, and which is properly labeled also. Now, if I have defined the x-axis as the categorical variable, y as continuous, you can exchange this also. That would just make your, so let me call this as y and this as x. It will not change your plot, it will just change the orientation. So now you get the boxes which are horizontal, and your y-axis, which is the continuous variable, is on the x-axis now. So if you are comfortable reading plot like this, which is the vertical box plot or the horizontal box plot, you can choose to plot accordingly. So now let's talk about how to plot categorical variables. Now for categorical data plotting, as I have told you, we have two very popular charts, which is one is known as the bar chart, the another one is known as the count plot. Let's try to understand both with example. Now in order to plot a bar chart, we need to have one categorical axis and one continuous axis in such a way that each category is having one number against it. For example, if I'm having a data of let's say the average score of various subjects, so the subject name, average score, then another subject, average score, then another subject, average score. This kind of data can be plotted as a bar plot or a bar chart. Let's try to see one example. Let's say we have three subjects, A, B, and C, and we have the average scores as 100.2 and 89, and then let's say 88.3. Then if I plot a bar plot, so SNS dot bar plot, x is equal to capital X, y is equal to capital Y, and here we have the plot. You can see that almost all the three numbers are on the same range, so I'm getting 3 bars, which is very similar in the height, because one is 100, another one is 89, another one is 88, so approximately the same, right? So we have one category against which we have a one number, category number, category number. How we can do this in when we are given with the data? Now remember in the last video, and if you guys haven't followed that, in advanced pandas function, where we have learned about how to perform data analysis using pandas, we have talked about a function known as value counts. And if you do not know about it, let's say this is my data and I want to know how many males and how many females we have in this column. So the very quick way of doing this thing is df.gender.value_counts, and we will get the category wise count of the category wise count. Now if I reset this, reset underscore index, I'll basically get a data frame where I'm having the name or the index column with the category and the gender column with the count. Let's try to plot it now. So I'll preserve this in a variable known as A, where A is my data frame. So I will write A is equal to this, and how my data frame A looks like. So A looks like this. So we will say SNS dot bar plot x is equal to A of index and y is equal to A of gender. Now here we have the bar plot. If you want to change the x label and y label, we can do that. So plt.x label, I want to keep it as, let's say, the gender, and plt.y label, I want to keep it as, let's say, the count. And here we have the spelling is wrong. label. And here now you can see that the axis has been correctly named. Let's say I'm using group by command. So df.head, and against each category for, let's say, internet service, I am finding out the average monthly charges. So df.group by internet service dot aggregate on monthly charges, and I want to find out the mean. So I'll get a data frame. Now this data frame is having index as internet service, monthly charges is basically my average. If I reset this also, then the index will become one of the column. So now we have internet service and we have monthly charges. Again, I will preserve it in a variable. Let's call that variable as b. Now how my b looks like? My b looks like a data frame. And now I can plot it. So sns.bar plot x is equal to b of internet service and y is equal to b of monthly charges. And if you want, you can rename the y-axis. So plt.y label, and I want to keep the y label as, let's say, the average monthly charges. And here we have, okay, again spelling is wrong, label. And here we have the proper looking bar plot with various internet service and the average monthly charges against each internet service. Now this is how you can generate a bar plot. So let's say now your objective is to generate a count plot, which basically means against each category you just want to represent the count of that category with the bar. In that case, you do not have to specifically use the bar plot. You can simply use the count plot functionality. So let's learn how to do it. sns.countplot, and let's say I want to plot internet service. And here you can see we have the count plot. So we haven't aggregated the data. The count plot will do it internally for you. There is one very useful functionality that comes with count plot. Let's try to understand it. Now let's say I want to look at the count of DSL as the internet service, but within DSL, I want to understand how many customers are churn and non-churn. So within each category, I want a subcategory. That is something which you can add just by using the parameter u, HUEU. And I want u as churn. And just see the magic. Now within each category, you have a subcategory which is represented by the column churn. Now here you can see one thing which is very interesting. Here the count of customers who have churned is highest for fiber optics, which is represented by this orange bar. And the count of customers who have not churned is highest for DSL as the internet service. But these kinds of insight is difficult to find out in this plot, right? In this plot, I can only say that fiber optic is having highest number of customers, but the interesting point is that it is having highest number of churn customers. Now that is the usefulness of using U parameter. So U is nothing but adding a category on top of a category. That's how simple it is. So this was all about how to generate various plots in Python using Matplotlib and Seaborn. We have discussed about very limited number of plots, and the reason I have not taken you to multiple plots is because if my objective is to perform data analysis, these 4 plots are more than enough to derive any kind of insights, and we will apply these 4 plots in the next video to understand the pattern in YouTube data. I hope this module was informative and really useful for all of you. If you like this video, give it a big thumbs up, share it with your friends, and don't forget to subscribe to our Scalers YouTube channel.